optimization, the key is first solution. But before he comes on board, I know it would interest you to want to know um, a little thing about our speaker. Of course, as you can see on screen, Engineer Chikwebuka Duru is a dynamic project engineer at REN Tech Engineering and a reservoir engineering trainee at Lasse Engineering in Port Harcourt, with a passion for advancing hydrocarbon recovery through innovative reservoir engineering and machine learning solutions. He holds masters in engineering with distinctions in petroleum engineering from FUPRI, and of course, I want to believe that's a typographical error. He holds, all right, sorry about that. So he holds BSc, I want to believe, in with distinction in petroleum engineering from FUPRI and a master's in engineering in electrical and electronics engineering from Nile University. Above all, his expertise is in Petrel, Eclipse, Prosper, Ember, Techlog, and this expertise has driven significant achievements for him through the engineering and petroleum space. Please, you can connect with him via his LinkedIn. That is the link. You can simply search for Chikwebuka Gizito Duro on LinkedIn, and you definitely have a way to connect with him. Please, this moment, let us welcome our speaker on board, Engineer Chikwebuka Kizito Duro. Please, you have our attention.
Thank you, Jamie, and good evening to everyone present. Good evening, Dr. Elvis. How are you doing, sir? Also our YP chairs and co-chairs present in the house, and our section chair, Dr. Adetuna. I'm really happy to be here. Jamie, that was not a typographical error. I actually hold a master's in electrical electronics engineering. So sorry, I have two masters. My
Wow.
BSc was.
I apologize. I apologize, sir.
No problem, no problem. So I have electrical electronics where I measured in machine learning and petroleum engineering where I measured in reservoir engineering. So today's topic, as rightly introduced, let me try to share my screen. Please give me a couple of minutes. I think I'm okay. Let me see. Can you stop sharing your screen, Jamie?
It's all right. It's done, sir. You can move on.
Okay. Can you see my screen?
Of course, sir.
Can you still see it at this point?
Yes, sir.
Oh, okay. Okay. So my name is Chukwebuka Kizito Duru, and I'm here to take you on a lecture, Application of Machine Learning in Hydrocarbon Recovery Optimization, the KISS first solution. My special gratitude goes to God, obviously, then to SPA, especially the Warrior section, for giving me this opportunity to share the little I know. I'm a strong believer in sharing what you know or teaching. That's why I keep telling my friends that after a while in the industry, I'll most likely retire back to the classroom. So I enjoy sharing the little I know because I believe it's a means of learning and it's a means of getting better or getting better in whatever you find yourself or whatever you do. So I'm really grateful to SP for granting me this opportunity. I'm grateful to my company, Rentech Engineering, also. For us to have this conversation, please, I know Faye said nobody should interrupt me, but not that I'm asking you to interrupt me, but I would like us to have a conversation. It's a lecture. It's not a presentation. A presentation, I wouldn't want an interruption, obviously. But in a lecture, I prefer my lecture room to be conversational, right? So we'd have conversations through every stages of this lecture. And I hope to hear the little I know and also learn something while living here too. Okay, so for our outline, this is the outline of this presentation. So I'm going to give you an illustrative introduction. We'll discuss problem statements. Faye listed one. subsurface complexity. I was asking myself, did he actually get to look at my slide? Because I know he did not. So I was surprised but then he's also in the industry, so I'm sure he's suffering what I'm suffering and what led to this framework. Obviously, we're going to discuss our proposed solution and the hybrid workflow we are implementing, the significance of the work, and obviously conclusions. So first, real life scenario. Let's say a week from now, you are back, obviously you are back at work and your company has implemented the KISS first framework, and your colleague resumes his usual morning routine. So he comes into the office, he turns on some system, he goes to the kitchen to get a cup of coffee or a cup of tea, whichever he prefers. And on coming back to his desk, he finds a notification that asks him to maybe increase his choke size to 32/64. And the notification is asking him to either accept or reject that recommendation. He accepts, he feels it's a good idea. So he accepts for whatever reason. And bending down to get maybe a biscuit from his drawer, he raises his head and sees another notification. This time asking him to maybe increase the flow line from his separator, increase the valve size to 50%. And he accepts. But this time now he's now curious. What is all this? Like usually he doesn't get to implement changes this fast in his field. So, and he calls you. Unfortunately, he's not here. So he calls you that he knew when to attend his first lecture and asked you, please come and give me an overview of this framework. Well, that overview you are about to give him is what I'm about to give you now. So he has to get the overview before the training, right? Problem statement. But before I show you my own problem statement, Feyi has listed one. I would like us to unmute our mics. Please raise your hand so it won't be rowdy. And let's discuss what are the problems you are facing in your own field. I want to really hear if other persons are seeing what I'm seeing, or if they are suffering what I'm suffering from our own. So tell me, what are you suffering at your own wellhead or whatever asset you're managing? What are the problems you're seeing there, please? I'm sure we have production engineers or reservoir engineers here. Anybody? You must not be, don't tell me the name of your company if you're afraid it's going to affect, what's it called? What's that word for it again? If it's a privacy issue, okay, let's make it this way. Tell me general problems in reservoirs, in your field or in any other field that you know of. So this one gives opportunity for even students to tell me problems they know of that you can face in a field, especially in a mature field like the Niger Delta. Sorry, a mature basin like the Niger Delta. It's supposed to be a conversation, oh, gentlemen and ladies. Okay, Kachi, please, go ahead. Please, you have to help me because I'm not seeing people raising their hands. I'm sharing, so a lot of blocking everything for me.
All right. I think I am going through the comment section. So if you permit me, I can read some of the comments there.
Okay, let's Kachi raise his hands first before we read the comments.
Yeah, so I'm guessing in a field, a problem that you can face is reduced flow rates. Because after you've drilled the wells and you've tapped into them for production, over time the flow rate will reduce because the wellhead pressure is not or the reservoir pressure is not as much as it was initially.
Yes, very true, very true, very true. Thank you so much, Kachi. I really appreciate that. Feyi, please.
All right. So from the comment section, Engineer Nelson mentioned water cut issues. So I think
Water
that's
cut
another.
issues.
Yeah,
Okay,
that's
okay.
another.
Thank you so much, Engineer Nelson, and thank you for reading that out for me. Any other person, please? Does any other person have any other issues they have seen or have faced or have heard of? You must not have faced it yourself,
Yeah.
but maybe through literature. Okay, water inflows, that goes with water cut and water coning. Okay, that's good. Sand production, very true, very true, very true. Loose sands and the rest. Any other person? High water production, BS and W. Okay, yeah, the same thing. Okay, let's move forward. But if you still have any issue, please keep posting it. I think I've gotten access to the chat so I can see it from here too and highlight it. But if you notice any, keep posting it. So let me go back to my presentation. Okay. So this one is for you, subsurface complexity. I think that was the first thing you listed yourself. So obviously, this is no news to anyone here. We all know that our geology is heterogeneous, and it's very complex. Obviously, the interactions between our rock and fluid is also a very big problem, wettability and all that. Obsolescence in old wells, conformance problems in mature reservoirs, uh, gas flaring, yes. Nigeria is a signatory to the 2016 net zero gas agreement. And some companies are actually moving ahead in it. I think Shell announced something. I think Shell is now at 30% or 20% gas flaring with the sale of their SPDC to Renaissance. I think they were at 20% or zero. I've forgotten. So if Shell, most companies are actually doing something to minimize their their flaring and all that. I think Aradel has a digitized oil field. They recently implemented a digitized oil field in their own. So inadequacy of traditional reservoir engineering, obviously decline curve analysis, material balance, taking a lot of time to calculate numerical simulations, and so on and so forth. Obviously, and most of these technologies or these traditional reservoir engineering tools that we use lack the ability to connect non-linear relationships in large data sets, right? So there are some things that are obvious. If you have a high water cut, for instance, things that can contribute to your high water cut could be channeling, could be obviously high drawdown, could be water cooling and all that. So those are obvious, right? But then there are some that are not that obvious, that are very non-linear. So our current tools may not be able to connect them, right? Let's see again. We have data quality issues. Yes, we keep talking. I just spoke of the data sets we have, but then the data we are getting are a lot of them have missing values. All of us, I'm believing everyone here have seen a production data, for instance. You are sure going to see missing values. You are sure going to see inconsistent format depending on who is sending you that data, right? If your PVT is sending you a data, the format you're probably expecting it in PSIA, and she's giving it to you, or he's giving it to you in PSIG and stuff like that. So measurement noise and all that. And there is something I talk about as a machine learning engineer myself. I complain that a lot of us, what is happening to a lot of us is what I like to call the model fever. So everyone is building a model. Every machine learning engineer you touch or you talk to, or everyone that learns one or two things from AI tries to build a model, right? Well, building models are good. Even our ChatGPT is actually a model, LLM. It's a large language model. But then, if the ChatGPT was designed to have an interface, there is a pipeline, right? A visual interface where you, as a normal human being, can type in normal words. The back end interprets and sends you a feedback, right? So if you go to ChatGPT and say, who is Chukwuebuka Kizito, there's an interface for you to type that. There's a chat box. There is a keyboard that pops up if you tap on your screen and stuff like that. So there's an interface, there's an end-to-end framework that connects that. Yes, just one model or more, but there are other pipelines that connect it. But then in our space, you get to see a lot of, especially even students. I really encourage students to do a lot of research because I tell them you learn more from your project work than info from your years in the classroom, right? So you are building a model, but that model you are building, have you thought of how to add it to what is already in existence? And even if you want to make it independent, have you thought of making it sufficiently independent in such a way that it can be easily used? First of all, if it's solving a problem, I believe whatever model you're building should already be solving a problem. Now, is it end-to-end? So does it have a rigorous data pipe? If you are building one for our industry, yours should have a rigorous data preprocessor because our data are very large, one. They have a lot of missing values and inconsistent format depending on who is sending it to you, even if you give it out to an operator to do your lab work for you. To a service company to do your lab work for you. There are algorithm selection issues. You have to have a model interpretability. Obviously, in this case, there is a real-time deployment because we are dealing with reservoirs, then the faster you get the information and the faster you implement it, the better for you, because a reservoir is not going to sit down waiting for you. If you are doing an EMBAL, what's it called, or eclipse simulation, for instance, it takes you a couple of weeks. It takes you a couple of weeks at least at best, if not months. It takes you a couple of weeks at best to run a proper simulation. And by the time you're running a proper simulation and getting your results, your reservoir has changed, because your reservoir is not going to sit down and wait for you, right? And all that. Well, proposed solution. Now let's discuss what is actually possible. So before I tell you what I'm proposing, I want to hear what everyone here thinks is possible from literature, from what you have read, from your own experience. What do you think is actually possible with the, what's it called? With the reign of AI and machine learning, and my friends usually say machine learning will take away, will collect our jobs, or AI will collect our jobs. I don't think it will, but then let's discuss what is possible. So please, can someone tell me what they think is possible? Okay, let me see the charts. Oh, someone said pressure maintenance, loss of circulation, corrosion issues. Yeah, good. Flow line issues. Yeah. WAS and the rest. Okay, that's good. That's good. Corrosion issues too. So now I really want to hear from us. What is possible? What do you think is, what solutions do you think is possible? Let's discuss. Because I know that this is not the best. For those of us that were in NAIS, that was in August, the framework I presented at NAIS, that was the version 1. This is version 2. A lot of things, a good number of things has changed from what was presented there then and and this. Although I already started upgrading it before I sent in my paper for publication. So this is basically version 2. And maybe by next time we'll have a conversation. This is first framework, version 3 or so will be out. So I know there are a lot of things that are possible. So tell me, what do you think is possible? It's a conversation, it's a lecture, please. I'm expecting responses, except no one is listening to me. Monitoring, yes. Real-time information, very important. Real-time, thank you so much, Callistus, for that. Real-time information is very, very important. And it's possible, yes. It's very possible, especially with sensors. I'm sure some of us can be here and see the house cameras we have at home. I'll control the lighting and the fridges in our house in real time. So it's possible too in our wells. So yeah, it's very possible. Thank you so much, Callistus, for that. Can anybody give me more? I really want to hear from us. Automatic data collation and cleaning. Thank you so much, Kachi. Thank you so much, Kachi. I really appreciate it. Automatic data collation is very possible. It's very possible. More efficient remote operations. Thank you so much, Cariton. I really appreciate that. Yes, more efficient. So you could control your reservoir or your well from even the US. So your well in the Niger Delta, you could be in the US and you control it, obviously. So more efficient remote operation. Thank you so much. Process precision. I saw a Zoom user. So whoever the Zoom user is, thank you so much. Yes, your process could be better and could be more precise. Thank you so much for that. Let me hear from us, please. Well optimization. Yes, your well can be optimized, but then optimization gives us a broad frame. When you say optimization, in what perspective? From where are you optimizing the choke size? Are you optimizing the entire well in terms of completion and the rest, which is also a good idea. Thank you for that. So that means you're thinking of even from the very stage of drilling, if we start thinking of how to optimize, which everyone should be doing already though. So thank you so much for that. Thank you so much, Efe. Well optimization, yes. Anybody? Okay. You can still keep bringing it in and I'll look at it again. Okay. So now, what is possible, like I said? Let's see. What am I proposing? Let me see. Someone has sent in something. Choke size, like a position. Thank you so much, Callistus. Yes, controlling your choke size is important. Controlling your choke size is very, very important. And there are limits to what you can do, though. So you can't flow in full choke, right? But then knowing the best choke, and if you increase it too much, your drawdown would. If you increase it too much, you have a high drawdown. And if you reduce it too much, you won't be producing at your optimal capacity, right? So knowing what's the best choke size to put it in or to choose is very important. Thank you so much for that, Callistus. So let's move forward. So we developed, sorry, we already developed. I prefer to say we are developing, because at every turn I'm looking at that framework and I'm thinking of something new to add or something new to make it better, right? Because nothing is perfect, only God is perfect. So we developed a modular, deployable machine learning framework specifically designed to optimize hydrocarbon recovery. Now, it is modular. Okay, I think someone sent in a chat. It's popping up here. Let me see. Effective implementation of reservoir engineering data, the material balance and production curve data. Yes, implementing it effectively is very important. So it's not just about doing something, but yeah, implementing it and implementing it rightly. Thank you so much, Nolly. So let's see. Okay, can we have the best of both worlds? Physics complementary time data driven models. So someone still let me touch on Nolly. So Nolly said effective implementation of reservoir engineering data, the material balance and production curve data. So in the industry, we cannot totally throw away material balance. It's very important for us, especially as reservoir engineers, right? It's not possible to actually throw it away. It's not possible to throw away your production curve data, your decline curve analysis, and the rest. Well, I would not say it's not possible. Everything is possible in life, but we have not gotten to the stage whereby, or have not seen technology enough that makes decline curve analysis non-relevant. But can we make it better, and how can we get the best of both worlds? Right? I am proposing machine learning, but then I know that this decline curve analysis, for instance, is very important. I know that my material balance is very important, and these are all physics-based. Can we get the best of both worlds? So please, can someone answer me that? You say yes or no. And if you have a why, I would really appreciate. So if you say no, tell me why. If you say yes, tell me why. And let's see. Anybody. You can speak, or you can raise your hand and speak, or you type it in. I would really appreciate. Okay. Faye, please,
Yeah,
if
Engineer Duro.
anybody typing an answer, tell me so I could just move ahead. Because I think my 40 minutes
All right,
is
it's all right.
trying to. Okay, once anyone types in an answer, and please, if you have an answer, just tell me why. So this is the workflow, the hybrid workflow we are proposing. So you will have your upload. I don't know, can you see my mouse? Let me know if you are seeing my mouse.
Yes, sir.
Can you
Yes, sir.
see my Okay, so at least I can use my mouse to direct. So we have our upload data here. Now this, okay, I guess when I show you the dashboard, I will explain some things in better details. But then our upload data comes into our machine learning prediction. This machine learning prediction it's a regression model, right? So, okay, I think I should explain something before I go into this. When we talk of frameworks are different from models, right? So a framework is a combination of multiple models. So our framework here has about 4 models inbuilt in it, right? About 4 models with various pipelines. Obviously, these models need pipelines to interface between them. And obviously, the interactions, like you can see here, you can see visualization here. This visualization here is a pipeline that connects between you, the end user, and the model itself, right? So when you're on your chat GPT, for instance, where you type in your chart and the rest, that is a pipeline that connects you to the LLM model, to the large language model, right? So for this case, we have our upload data that goes to our regression model, a machine learning prediction. Now, this regression model is a supervised learning. So I don't know if I'm going to, for those of, okay, I think I should explain the difference between this is reinforcement learning training, and this is supervised learning, and there's another unsupervised learning. Okay, Faye, you are raising your hand, please.
Yeah, sorry to
Faye,
to cut you short. Sorry to cut you short, sir. I know I made the rule, but I'm breaking it already. I apologize. Yes,
no
somebody
problem, no problem.
Kachi
That is fine. Okay,
actually
let me
dropped
catch.
something about the question.
Oh, okay. Oh, thank you so much for it. No, I don't need to apologize for that. I asked for it. It's a lecture. I prefer my lectures conversational than just um, only me speaking to myself. Everybody get bored and end up sleeping, especially for a field where some of us are not too, what's it called, hands-on on it. So Kachi said, yes, probably using some sort of semi-supervised machine learning model where you get your feature set using the data and physics compliant equation using machine learning for real-time prediction. Thank you so much, Kachi. Thank you so much. So now Kachi is proposing a semi-supervised. My team is proposed a supervised and reinforcement learning. So I'm going to, I think I should tell us the difference between, first, let me even ask, Kachi, please unmute your mic. Are you a machine learning engineer too? Or please have you
Not in
dabbled into?
machine
Eh?
learning engineer, but yes, I've dabbled, but I'm not a
Okay,
machine learning engineer. Yeah.
okay, thank you so much. So please, can you, I wanted to do the definition myself, but like I said, I like this, my classes to be conversational. So can you tell us the difference between supervised, semi-supervised, and reinforcement learning?
Okay, so I'm going
Just
to
give
try
us an
my best.
overview. Don't give us a textbook definition. Just give us an overview that will make, I prefer to say, teach me like a 5 years old. So say it in such a way that if a 5-year-old would get an idea of what you're trying to say.
Okay, so for supervised machine learning models, you have your data sets, maybe your true data and everything. Then you have
Yes.
whatever problem you are trying to solve. You want a label. Let's say if you want to classify it, you want a label. Is this a choke or not? You have a bunch of pictures. Is this a choke or not? So you have your data
Yeah.
sets and you have the labels. So you have everything
Okay.
complete, your data set and the labels, and you can use it to train your machine learning model.
Yeah.
Semi-supervised is you have your data sets, but you are not able to get those labels that you want, or you don't have a lot of them. You just have little. So
Yeah.
machine learning is actually quite it's data intensive. It uses a lot of data. So if you don't have a huge enough data set, you can't do much. But when you apply your equations now to get your label sets, you can use that to populate the rest of the data and do whatever you wish to do. So that way you can sort of artificially make your data sets larger. That's how I view it. That might not be very correct. Then the last one, reinforcement learning, is sort of like you make the computer learn, or rather your program learn by itself by sort of assigning rewards and punishments to whatever task that you've given the model to do. So the model sort of grows in a way. You tell it do this. If it does that improperly, you assign a reward and it's able to infer what the reward entails. And if it does it wrongly, you assign a punishment and make it redo that step to get the reward. So that's how I
Mm.
see it.
Okay, sorry, we forgot one. Can you tell us unsupervised? So there's supervised, there's semi-supervised, there's unsupervised. I forgot
Unsupervised
that.
learning, you have absolutely no labels to make use of. So that way you apply things like clustering and the rest. So you are trying to infer data. You have no labels to predict, but you are trying to break it down,
Thank you so
infer
much,
it. So
Kachi.
use
Thank you so
clustering
much,
and the rest.
Kachi. Thank you so much. Thank you. Please, can we clap for Kachi, please? Can we clap for him, please? Please use the what's it called? The emoji or whatever it is to clap for him, please. Thank you so much, Kachi. We really appreciate that. So Kachi is basically very correct. So for supervised, you have a label and you have the data. For unsupervised, there is no label. You have the data, yes, so you can use clustering and the rest to segregate and identify specific or unique features. And for reinforcement learning, as your machine is learning, you are rewarding, and if it does not do it properly, you, for the lack of a better word, punish. So thank you so much, Kachi, for what's it called? Telling us the difference between all this. So yes, so for this we used a machine learning prediction. Now there's something I really wanted to. So yes, this machine learning prediction we use here is a supervised prediction, right? Now this takes in the uploaded data. Now this uploaded data is a situation whereby this is an old well or an old reservoir, and you have been obviously producing for it for quite a while, and you wanted to implement the keys first solution. Obviously, you need to get in the production history so that the machine will learn on that production history. You need to give it the PVT data, the BOI, the initial pressure, the SG, and all that, the API, everything. You need to give it the entire fluid and reservoir data. You need to give it the production history. Obviously, whether for new or old wells, you obviously need to put in your well coordinates, because whether for new or old wells, if you're implementing the KISS first solution, even for a new well that doesn't have a production history, your well coordinate needs to be uploaded, right? And your food and reservoir data, because you must have taken the core for the cores of that well for core analysis, for SCAL and all the rest, right? So you need to put in all those information, because if you have them, but if you don't have them, your live sensors will read out those it's carried out. So we upload our data to our machine learning, which learns on that, the supervised model. So a supervised model learns on that is a regression model. So now there are regression models, there are classification models and all that. Let me not take you in too deep into machine learning or AI. But then let me call this a layer. Yes, it's actually called a layer. So the result of the machine learning model, it serves as a layer for the reinforcement training, the reinforcement learning. So the reinforcement learning sort of gets a jump start. Now, why is it getting a jump start? It's also learning from live feed sensors. So your live feed sensors are sending it information in real time. As they hot, they send them. I hope we all will be worrying as well when they carry last. So allow me to teach in pidgin too. As they hot, as they happen for field, they send them down. So as it's happening in your field, your live sensors are picking it up, they are live, and sending it to your dashboard, and your models are training on it, right? Now, your reinforcement learning trains on this information, that which it got from machine learning, and the live sensor it got. It trains on it, gets better from it, and gives a recommendation. Yes, accept or reject. Remember the scenario we gave earlier? The staff that came to work to get saw accept or reject on his screen, right? So accept or reject. Now, if you accept and your system already has the digitized oil field, like RRDL, for instance, it sends it to your feed API. Now, to simplify what an API is that technology that allows you to use your phone and control the lighting in your house. I'm sure some of us have seen that technology where you can be at work and you switch off the AC in your house or switch off the lights in your house. That's called an API. So it helps in Internet of Things, right? So it connects, for a lack of a better word, the software to the hardware. For a lack of a better word, that is not actually the right word. But then it helps you to control physical things from what is it called? Using your devices anywhere you are. So your feed API obviously is connected to your oil feed equipment, and oil feed equipment implements whatever instructions you are given. So in changing choke size, changing your valve, obviously change the choke size, your what's it called, flowing pressure your tubing head pressure would increase or reduce and all that. The oil feed equipment will obviously send a live signal to the sensor, right? So the sensor is telling you how your well is reacting at that. So your sensor is taking information of how your well is reacting to that new information, how your well is reacting to itself already, because it's producing. This time we have been discussing, your well has been producing, your reservoir has been producing, and your reservoir has not been the same in the last 5 or 10 minutes we have been discussing. Again, the changes might be negligible to you, but to a machine, those changes are not negligible. Those changes could be what could prevent your reservoir from channeling on time if you actually prevent it, right? So let's say as you increase your choke size to 32 as initially recommended, and it notices that the pressure is beginning to cause the reservoir formation to crack or something because of high drawdown. You're getting that information. You could reduce it on time if you're fast enough to prevent that channeling that is about to happen and stuff, right? So basically, the cycle continues. So it learns. And obviously, there's a visualization. So you get to see everything that is happening. You get to see your charts. You get to see, I'm going to show you some of those. So you get to see how your reinforcement learning is learning, like Kachi told us, how it is rewarding itself and all that. You get to see how, and let's see that. Let's even see that. Let me not tell you what you get to see when you could easily see them. So first, this is how the dashboard looks like. So this was built with Streamlit, for those of us that are into machine learning. This was built with Streamlit. You could see the upload, you could see the live sensor field, you could see the machine learning prediction, could see the reinforcement training, you could see visualization, you could see recommendation and all that. So you could see our well overlay. So your well, you have to upload your well coordinate, whatever the case may be, or paste it. So I'm going to show you how to paste and edit some of that. Obviously, our rock and fluid properties, your BOI and the rest. Your Eclipse data, which is optional for you if you don't have your Eclipse data already. So for this, so you could see we have your BOI, reservoir temperature, viscosity, and all that. Basically, your initial water saturation, permeability, and all that. So you put whatever value you put in this first layer here changes in the bottom layer, right? Obviously, our production data for well K was uploaded in this instance. All these are just surface testing. This image does not have us connected to a live sensor, but I'm still going to show you what a live sensor feed would look like. Here we have, okay. So yeah, like I said before, you could paste and edit. Now, let me even go back a little. So for this, even for our rock and fluid property, you could upload it. So you could see browse files, right? So you could drag and drop files. So you could upload the file, or you could click paste and edit and edit the values if you already if you have the values handy and you don't have it in a CSV file or JSON file. For your production data, the same thing. So you could upload or you could paste and edit, or you could finish uploading. Like what I did here was actually uploaded, so you could see I uploaded. Then I still click on paste and edit just to look at it for looking sake, right? So that I'm able to take a screenshot of it for this presentation. But then for this, you could, after uploading your data, just like I said earlier, there are missing values, there are, what's it called? Like you could see here now, see here. You can see gas rate here was 0. From 814.52, you have a 0, then you have a 0, 1,800.57 MCF, right? Cubic feet per day. Now, although in this case, this production data, even without looking at it, even without being able to scroll through this data, I can tell you that maybe this was where we took our static bottom hole pressure. So obviously, if you take your static bottom hole pressure, you shut down for that day and take your pressure, right? But then missing values, inconsistent format, and all the rest. So you get to see them here to correct the ones you want to correct. But then you won't be able to correct everything. If you have a data page of over 10,000 lines, maybe your reservoir has been producing since 1970, for instance, or since 1980, every day since 1980, this is 2025. When do you want to start correcting that data set, right? So that is where this framework helps, because we have a data processing pipeline that helps you solve that problem, right? Let's see. Okay, yeah, live sensor feed. So your live sensor feed either comes as API or MQQ, uses the API or MQTT plugins. Prediction. Obviously, if you had a live sensor feed, it will show you, you will have your well contour, and your well contour will have your S axis, your Z axis, and your Y axis. And this Z axis that is appearing as 0, what you will have there will be your pressure value if this was connected. But then I took this offline, so okay, let me see. I think I should have, yes. So this is what your live sensor feed should look like. I just named this on well 58, well 4. But then you could name your well K, you could name it well 4L, well 4T, well 5TS or LS, sorry, and so on and so forth. So we have our timestamp. This timestamp will following the ISO 1806 standard, right? So obviously your live production, your gas production, your water production, your bottom hole, and your choke size. So this is 0.65, that is 65%. If you, what's it called? If you, what is that word for it? If you align it to 64 gauge size, it will tell you that should be around 65% of 64 should be around 40 something percent, 40, around 42 or thereabouts gauge size, right? About 42 thereabout, yeah, about 38, 42 thereabout. Okay, so let's see. So your machine learning prediction, now you could decide to predict for only gas rates or oil rates or only water rate or only your bottom hole pressure, depending on what you want to predict for. But in this case, I decided to just predict for everything. Let's see everything. So obviously you could see the graph was cut short. But you could see well A predicted production rates per well for well A. Let's see, what do we have here? Okay, yes, you could see your decline curve. I've not fine-tuned it, but then you could see your forecast. You could see it was trying to history match your production. So the dots are the actual production. The blue tick line, the blue line is your harmonic fit, and the what I call this gold or orange line is your forecast, right? So we have your this year starting this. So you get to choose. Now you get to choose a value where that will help you to fit or history match your production. But then the model gives you a range so that you can't exceed, depending on your production history. So it's not as if there's a fixed range, no. Depending on the data you are giving it, it has learned from it and it tells you, or maybe your this year starting desk should not exceed 50, or should not exceed 34, or should not exceed 20, or should not even exceed 5. I think, yeah, there was one that showed me that this year should not exceed 5. Though that one was a very new West, just had a little production history. Okay, so let's continue. Obviously, the model tells you your reservoir volumetrics, so initial water saturation, your oil in place, your gas in place, your cumulative production. And obviously, it predicts your bottom hole pressure per well. So for each of the wells, so you could see well A, well B, well K. It tries to predict your bottom hole pressure at that instance. Now, if it was connected to a live sensor field, it will give you at that time and predict your future one, your future, what's it called? Bottom hole pressure. Okay, so our reinforcement learning. So the next thing will be our reinforcement learning. Kachi spoke about rewards, right? So on this graph, you could see rewards on the y-axis. This was also cut. So the episode is on the s-axis. So now this model trains on 10 episodes per batch. It's, like I said, it's real time. So it's training, right? But as it's training, it is saving. It is saving that thing. So it is now less for you. When I tell people that there's a big problem in machine learning, or what we call the opaque of machine learning, where opaque, in the sense, no opaque, something you can see through, right? So most people just know that this model, you put in information A or you ask for information A and it gives you results B, or you put X and you get Y, but you don't know what happens in between, right? Now, to avoid that, to give the engineer a little bit of control over an asset he's managing, right? Yeah, to give the engineer a control over an asset he's managing, he has the opportunity to come here, train the assets, train the model. So despite the model has been learning since, he can decide, okay, for the last 10 episodes you have trained, train on that, learn on that. The model learns new policies, a proximal policy optimization. So PPO, it learns new PPO, right? And it gets better. So as it learns, you could see the graph. As it learns, and as it gets better, it rewards itself. So and the more positive the rewards are, the better your model becomes. So currently, initially it was around minus 0. Let's say that should be around 4.8, 4.7. It trained. After training complete on 10 episodes, it increased to 0.2, minus 0.2. But then, as the engineer has control, the engineer can say, okay, actually prefer, obviously, as you train, it is recommended that you save the agents that you have trained. So you get to save multiple reinforcement agents, reinforced learning agents that can use to optimize your work. So if you saved it and maybe after a while you feel, okay, the results you are seeing, you're not satisfied with it, you could go and load your last checkpoint. So load the last saved agent that you felt was better that you saved. So if you load it, now in this case, I saved, what was it called? I saved the last agent that was at minus 0.48, right? And I decided to retrain again. After retraining, you could see it did not get all the way to minus 0.2 that it got to. It went to minus 0.3, right? Now, if I saved minus 0.2 and maybe my reinforcement learning trained and got minus 0.3, obviously the reward has reduced. So it's not going to reward this. The reward it got has reduced. And obviously, minus 0.2 is better because the more positive it is, the better the what's it called, the model is, right? The better the results it will give. I could easily just go back to my last safe agents, that is the minus 0.2, and pick it since it's better than minus 0.3, right? And obviously, whatever prediction, I can easily send it to field operations control, which obviously connects to my field operations API to send control actions in real time. So in that case, you can see here now, you can see send control actions to field API. If I send control actions to field API, my field API chain carries out whatever recommendations my reinforcement learning has recommended. So here you have obviously your virtualization, so your bottom hole or your Eclipse data if available. And in this case, it is estimating your bottom hole estimation for well A is saying your surface tipping head pressure is at 262. Your depth is at 9,000, those are constant. Your fluid density and all that, you get to see it. So your static bottom hole is at 3,892.40 PSIA. Now recommendation. So you get to see the recommendations. When you go to the recommendation dashboard, you get to see the recommended pressure to flow optimally. So RL/machine learning optimize the recommendation to tell you what pressure to flow at. That will give you the best results. So you're getting a gas of 7,100, 712 scuff per day, but then you'll be getting an oil of 2,322 standard barrel per day, right? STB per day. And to achieve that, your optimal valve should be at 50 and your recommended choke size should be at 32, right? Obviously, I forgot to state the accept or reject that we spoke about here. So you can either accept or reject this recommendation. Significance and impact. Now, this model has bridged the gap between theory and practice, right? Now, most of us, especially machine learning engineers, have built different models. But most of our models, like I said earlier, are not fit for purpose. They can be implemented or they cannot be used in practice. Now, this has shown us that we cannot just make theories. Some of us, let me go back to what is possible that we, I think it was Callistus. Callistus spoke of choke size. Okay, yes, choke size. Someone spoke on real-time. Okay, that was the Callistus, real-time information. So yeah, this is showing you that you can get real-time information and monitor your well in real time wherever you are, whether in the US. You can monitor a well in data here from the US or the UK or whatever part of the world you find yourself, or from Lagos head office, anywhere you find yourself, right? You can, what is it called? Your process precision, yes. So you can optimize your strategy, well optimization, yes. So you can optimize your strategy, you can optimize your well from anywhere you are, and so on and so forth. So this has shown us that it is possible. You can enhance recovery efficiency. Obviously, if you optimize your well, your recovery will be better, right? Your recovery percentage will be better. And accelerating digital adoption. Obviously, for you to implement this, you have to have a digitized oil field. And for you to have a digitized oil field, you are accelerating digital adoption. Things becomes better. The stress reduces, actually. I usually tell people, engineering is very sweet if you have tools. If you have your tools, engineering is too sweet. Contribution to sustainable operations. Obviously, this work could add to academic and scientific advancement. But then, most importantly, I'd like to emphasize real-time decision support. So you don't just do your Eclipse simulation or do your material balance analysis. Then you sit down maybe with a team of engineers, which is also good, yes. Sit down with your team of engineers, and it takes you 3 days, 4 days to make sense, or 1 week to make sense of the data in front of you, which you and I know very well that you're going to miss 1 or 2 clues, and which you and I know very well that your reservoir is not going to sit down there waiting for you. Your reservoir is going to be changed. When you're in your boardroom, going through the various what's it called, graphs, and making sense of all the various curves that are presented before you, your reservoir is changing. The reservoir you're analyzing is no longer the reservoir that is in existence. That one is past reservoir. This one is what is happening at the. So this framework gives you real-time decision support, gives you a recommendation in real time. Now it's a recommendation. So like all recommendation, you get to accept or reject. So if it gives you a choke size that is maybe asks you to flow your choke at 64. You know you can't accept because Nigerian policy doesn't allow you to flow at maximum choke, right? If your company has a rule that you should never flow below, let's say below 16 choke size, you can never flow below 16 choke size. Even if it keeps recommending 16 choke size, you will reject, right? And so on and so forth. Let's see. Now, traditional method versus KISS first framework. Prediction latency. The best you can do in traditional method is to predict to the very last minute, but you can't predict sub-second. So even if you have a decline curve and you're able to do a decline curve in days, most decline curve I've seen are usually in days. But even if you manage to do it to the very last hour or to the last minute, good and fine. But this framework will give you in the sub-second, right? Control adaptability, obviously, what the traditional method are all manual and rule based. Why this? Not. I'm not saying you should throw away the rules. The rules helps to guide your decision, right? As the engineer and control. But then this framework is learning on policies. So it's not just learning on the information you are giving it today. The reinforcement learning is not learning on the information it just has today. It is learning on the information it has previously too, from the history data it has, from the changes it has observed from your well. So those non-linear changes that you would have overlooked or your data would have overlooked or you wouldn't have probably implemented or uploaded to your MBAL or so, this is looking at it and is making sense of it. So it's learning policies and it's doing all this in real time, right? Your computational cost, obviously, this is way cheaper. The scalability, this can be scaled to the number of wells you will have and saves you a lot of time in doing that. User interface, this is intuitive and very interactive, while the other one is technical and non-interactive. Learning capability, the other ones do not have, cannot learn, but like I said, this has a reinforcement learning, so it keeps continuous improvement. It's getting better by the day. So your model yesterday is not your model of today, it's better. Now, hybrid physics-guided driven approaches are powerful tools for the ERP industries, and most of them unlock remaining potential. This would obviously unlock remaining potential of mature fields in shorter time frame, and is very, very cost-effective compared to standard integrated modeling and workflows. It ensures uncertainty and risk are captured within the identification of opportunity. So the risks are captured on time. It's not just that you know that this would happen. You know that your well will finally cone one day. But were you able to capture it on time? Were you able to mitigate it? Were you able to delay that coning? Because if you capture it on time, it gives you opportunity to delay it, right? It gives you opportunity to make changes that would elongate your well life and optimize your flow, right? And all that. So I listed a lot of problems before I started. Okay, before I even talk of my own problems, let's have another conversation. Let's go back to the various problems we have here. The various problems we have here, let's see, how many of them has this framework solved? So water cut issues, water coning, inflows, and the rest. Now, who posted that? That was Daniel Oduma and Engineer Nelson. So Engineer Nelson, please, and Daniel, do you see a way this framework will solve your problem? Your water cut issues in your well or your reservoir, or in the well or the reservoir you're referring to? Engineer Nelson, are you there with me? Okay, Daniel Oduma. Okay, thank you so much. Go ahead.
No, I think this is Jimmy speaking, please.
Okay.
I think
Okay.
Engineer Nelson is out of the
Okay,
space.
what of Mr. Daniel?
Mr. Daniel.
Daniel Odumu. They stay with us.
I doubt it, sir.
Oh, okay. Okay. Carrington.
Daniel,
I think Carrington.
Nadia Odumu
Carrington,
is
please.
here. Daniel
Daniel Odumu.
Odumu
Okay.
is here.
Daniel Odumu, please. Tell us, from what you have observed, at least from the little you have observed from this framework, is there a way you have seen that to solve your water inflows issue? Mr. Daniel, please. If you don't think it can, just tell us it can. That will be fine. Okay. I guess maybe he has dropped his phone and stepped out or something. Okay, let me go to the next. Please, if you feel you have an answer to any of these problems using the framework or a better solution, you can raise your hand and let's have a conversation. Like I said, I prefer my class being conversational than just me talking, right? Mr. Carrington, you spoke on sound production. Do you see a way this framework will solve your sound production issue? Or will solve any sound production issue for a word that's producing sound? Unmute your mic. I'm seeing your response, but I prefer you unmute your mic. Let's have a conversation. I prefer a conversational class. Sorry for putting you on the spot, but I prefer a conversational class.
Okay. Confirm you can hear me, sir. Good evening, everyone.
I can confirm you, man. I can hear you. Sorry. Good evening, man.
Okay, so thank you very much for your presentation, sir. With regards to the issue I raised with respect to sound production, although I am not entirely convinced, but
Yes.
from the analysis you made with the machine learning method you introduced to us, it may address the issue, but not fully. Not fully.
Okay. So
Because
can you tell
it
us?
doesn't provide practical recommendations on how to tackle the issue of sound production.
True. I've not stated it, but then I really wanted to. Please unmute. Remain unmuted. Sorry. So I really wanted to, from what you have observed, right? Yes, I have not provided any practical recommendation on how to handle sound production. That is very true. But then I would like to hear from your perspective. What and what information do we need to handle sound production in a well? Say, well K. Okay, yes, one of the wells I listed in this one was obviously named the well K. So let's say well K was producing sound, right? What and what? How do you think we can handle it?
Yes, I can hear
From
you.
Yes, tell us. So how do you think we can handle it? Let's say where K was producing sound. What are one of the few things you would do to handle your well that is producing sound? Do you get my question? Do you understand my question?
Sorry, the line is breaking.
Okay.
Please, can you
Can
come again
anyone
with the
hear me?
question? I think I can get you clearly now.
Yeah, I can hear
Okay.
you.
I said if you have a well K, a well K or well, your name is Carrington, so let's say well C. A well C
Okay.
that is producing sound,
Yes.
what approach would you use to handle or minimize your sound production from that well? Please, this question is not just for Carrington, please. I'm not trying to put him on the spot. Sorry. This is for everyone. It's a conversation. Please, this is an open class. Let's have a conversation. Let's learn. Please. Everyone. So I can see
Okay.
Mario here.
Can I
Mario
go
is my
ahead, sir?
brother. Please go ahead, man. Go ahead.
Okay, so in terms of sound production, I feel some of the control methods you can use are maybe you work with gravel packing. Then in terms of
Thank you.
operational management, you can monitor the production rates, thereby controlling the rates to minimize the sound production. And also,
Thank you.
most
Thank you.
importantly, you need regular well maintenance.
Very true. Very true. Thank you so much. Please, can we give Carrington a round of applause, please? Give
Did you
him, use
get
the
me?
emoji. Yeah, I got you. I got you so much. I got you. Thank you so much, man. Thank you. So now you said gravel packing. I will add screening to that using sunscreen. But you also said controlling your production, right? One of the biggest things, it was Callistus that highlighted choke size when we started, controlling your choke size. This model shot, that was even when I was giving my real life scenario analysis, what could possibly happen. It was controlling your choke size, increasing your choke size, or reducing your choke size. There are various reasons why it can be reducing the DD would help to mitigate sound. Please, what is DD? For those of us that senior man Mario, I greet you, Siswapo. How you doing, man? So please tell us what DD is in this case. So
hello, good evening, everyone. Didi is the drawdown.
good evening, Mario. Okay, yes, drawdown. Okay, thank you so much. Thank you so much. Yes, your drawdown. So reducing your drawdown, which obviously for you to reduce your drawdown, you have to reduce your choke size, which implies you end up reducing your tubing head pressure. Will reduce the sounds you are producing because it will reduce the pressure at which the fluid is coming to the surface, right? Now, this framework touched on that, highlighted that, might not totally solve all the problems. Like I said earlier, I am not telling you that I have a perfect framework. I don't have a perfect framework, but I have a framework that is workable and a framework that I will keep working on to become better as it goes. And like I said earlier, what I presented in NAIS was version 1. This was version 2. Maybe by the time we're having this conversation next time, I will tell you that a version 3 is because it's already in play. I'm already fixing some other things in it that I noticed earlier. So everything cannot be solved. Our reservoir, we are in a sandstone reservoir, and that is Niger Delta Basin. Yeah. It's heterogeneous, so we're going to once in a while meet fields that have loose sand and the rest. Yes, we're lucky to have some fields that are very well compacted and the rest that have compacted. But then you can meet a reservoir that has loose sands, and if you have loose sands, you're going to have what is it called? You're going to have sand production at one time or the other. But then how do you handle it? And like you rightly said, handling production, handling drawdown, putting sound screen, putting sound gravels. And this model can tell you what rates to flow easily instead of doing guesswork like we do most times when you're trying to change the choke size in your well, right? This model will tell you that. This model could tell you what type of sunscreen you should use, what type of gravel packing you should, or when you should implement it, and so on and so forth. But then most of us just do it at the beginning of drilling, right? Sorry, at the beginning of well completion and the rest. So let's see, what other problems do we have here? Okay, someone spoke on corrosion issues. That was William Okon. Please, Faye, hope I still have time before I'm enjoying myself and forget that time is going.
Yeah, actually, we are
Hope I'm
working
not
with time,
eating.
sir. You
I'm
should
still
try
within time, right?
not really, sir. You should
I'm
try
still.
and round up, sir.
Oh, I am not within time. Oh, sorry. Okay, in that case, let's move ahead. Thank you, Mario, for that contribution. Thank you, Cariton. Thank you, Callistus. Thank you for everyone for the various responses. Let's see, what do we have left? I think I'm almost done here, though. So yes, subsurface complexity. This framework handles real-time decision support that leverages live sensor data to capture subsurface dynamics. So as your subsurface is changing, your live sensors are picking it up. And as your live sensors are picking it up, they're sending it to the framework. And your framework, your models are learning on this information and giving you real-time decision supports that you could do or amend your strategies, your operating strategies to maximize your production and increase the efficiency of your recovery. So obviously, obsolescence in old wells and conformance in mature reservoirs. Still real-time monitoring that Callistus highlighted earlier with sensor feedback to inform optimization strategies, right? Glass flaring and subsurface facility inefficiencies. Your live sensor connected to your separator and the rest will tell you what you can handle, what first of all, your live sensors are already connected to your wellhead and to your bottom hole, but also to your surface facilities. This would tell you what you should be producing and what in line with what you can handle at the surface, right? Limitation of obviously have overflogged this issue of our traditional reservoir engineering tools being way inadequate to handle the large chunk of data our fields are giving us these days. Data quality issues, a robust data processing pipeline with cleaning, validation, and normalization. Obviously, a lack of end-to-end machine learning framework. Obviously, this is solved by a full machine learning optimization stack, pre-processing, interpretability, and real-time deployment. Thank you for your attention. But then I want you to go home with knowing very well that the future of energy, especially in Nigeria, lies not only in what we extract, but how intelligently we manage it. It's not just by extracting and extracting, but how we managing what we are getting. Thank you so much, and thank you for your time.
Please, we can use the clapping emoji for our guest speaker.
Am I the only one that's having issue hearing Faye? Faye, we can't hear you, sorry.
No, sir.
Okay, so I'm not the only one. Well, while Faye is trying to fix his
Hello.
network, please. Okay, Faye, we can hear you now.
All right, thank you very much. So thank you very much, Engineer Duru, for your presentation. You- you- you-
Your network is getting bad, or is bad already? So please, while Faye is trying to fix his network, we could visit spe.org/dl and nominate me for this presentation as a distinguished lecturer. Thank you so much. And please connect with me on LinkedIn. I have a series on LinkedIn titled Reservoir Fundamentals, where every week I discuss various fundamental issues in reservoir engineering and reservoirs. So various fundamental topics, sorry, not just issues, but topics in reservoir.
All right,
So Faye,
I
please.
guess I am. All right, thank you very much, sir. I guess my network is kind of disturbing this moment, but let's move on. Thank you very much once again, Engineer Duru. So this moment we will be welcoming questions and answers, and to anchor this part, I will be calling as he anchors the questions and answers. Over to you, Mr. Lawal.
Thank you so much, sir. Mr. Drew. I really enjoyed this session. And though I'm a geology student, so I don't really know much about this engineering and all, but the way you made the presentation, I really enjoyed it. And I think I learned a lot of things. And I know that everyone here also learned a whole lot of things that they will take back home and do some homework on it. Thank you so much, sir. God bless you. So now we'll be having our question and answer session. So if you have a question, either raise your hand and then I will call you. Sorry, can you hear me, please? Sorry, can you hear me?
Yes, we can hear you. We can hear
Okay,
you.
so if you have a question, please either raise your hand, then we record, or you type your question in the chat box, please. Okay, we have someone here, Callistos, Mr. Callistos. He has a question. Please,
Hey, you.
if you have a question, please raise your hand, or you can type them in the chat box, please. Wow, this is a lot. Okay, so thank you, sir. Thank you, Mr. Callistos. So I'll be reading the question now. Is there a way for the framework to monitor the non-company decision made by decision maker? This is just to save the whole process of saving recurring decision. That's the first question, sir. So the second question about sensor record passes it to the framework. The framework reads the information and gives feedback. But the part where you said controller save agents and all that, is there a way to track all those decisions as to the reinforced length you talked about? I have more, but we'll talk later on. So, sir, engineer, this is a question for you, sir.
Okay, thank you so much, Callisus, for these questions. Thank you so much. So let me start with the first one. Is there a way for the framework to monitor the I guess you meant non-company decision. I don't know. What do you mean by non-company? Please, Callisus, can you unmute and what do you mean by non-company decisions made by decision makers? Please, can you tell us what you meant by that? I would
All
want to
right,
answer.
sorry. Sorry, confirm if you hear
Okay.
that.
I can hear you. I can hear you, Callistus.
All right. So by non-company decisions, I mean, for example, where you stated um, the company won't want you to reduce stroke size and stuff like that. So decisions that are not induced by companies. For example, I'll just relate to the two questions now in this case. Let's say where you said the controller, which is basically seeing the front end, says he doesn't like this particular, let's say particular data, or let's say graph, let's say likes 0.2, like you stated, and not minus 0.3. Yeah. So now all those decisions made, yes, is they a way for this particular framework to like track it. Why? Because if you have, because obviously we're dealing with data, and there will be scenarios where you have recurring data. So now, is there a way for the system or the framework to actually track all these decisions so that, okay, me as a controller now, it's the same data. I don't have to like still tell the system what to do at that particular instance. You get, so it records then basically the reinforced learning that you talked about. Because from the framework, everything basically around the front end, from what I saw, is fully supervised. Yes, but although you stated where you, which is reinforced, giving rewards and all that, but I didn't really get to where it actually tracks all this and what it actually does with basically learning all this stuff.
Now, okay, if I understand you correctly, does it, in simple terms, you're asking if all the information it is gathering, is there a way it is saving it for future referencing and the rest?
Not just saving, not just saving now in this case, decisions on its own as well. Obviously, it's machine
Come
learning.
again.
Not just
You said?
saving it, not just, can
Okay.
you hear me now? Not just saving,
Yes, not just
also
saving
making
it, but
decision on its own based on past data that has occurred before.
okay, is it making decision on its own?
Yes.
Are you asking if it's
Already.
making decision on its own?
Okay, let me put it
Okay.
this way. Whether it's making already, it can make already supervised decisions in the past.
Okay. So in the recent, if it has said, if it had recommended using choke size before and I accepted, instead of recommending it again, can it just go ahead and implement it on its own?
Exactly.
Oh, okay. So first things first. Okay, you said not just saving, but so now this framework. Let me see. I don't know if my slide has that, but let me try to see if I can find it before I try to share it. I just pray one of the screenshots has it. Let me see. So, that is the problem with screenshots. You just not get everything. Okay, but no problem. This is fine. Okay, yes, one of the screenshots has it. So please, let me try to share the screen and show it to you on the dashboard. I think that makes everything easy. Where is that slide? Okay, it is here. It is. Okay, can you see this? Can you see log/monitoring? Callistus, can you see this?
Yeah, I can.
Okay, so for every learning, for every decision, for every information that passes through, because I think that's the simple term, information encompasses everything. So for every information that passes through this framework, there is a log. It logs it. So there's history. You can always go back and view your logs yourself as the engineer, right? Now, to answer your second question about if it can, instead of keep recommending, if you can go ahead and just implement, since you already accepted that decision before. No, I did not add that feature. And I am still not inclined to adding the feature. Now, this is the reason, right? I might have accepted a 32 choke size before, for one reason or the other. Or let's even make it better. I might have accepted a 48 choke size before, for one reason or the other. But my company wakes up today and maybe gives me, I'm just giving a scenario here. My company wakes up today and gives me a new company policy. Never produce at 48 choke size, or never produce above 48 choke size, something like that. If my framework would just implement decisions without me oversighting that decision, I would consistently have to be fighting the framework. Because if you just go ahead and implement it, after all, I've accepted it before. The framework is not in that boardroom when our MD walked in and gave that instruction for one reason or the other. I don't know if you get. So there are various reasons. This is just one example, a very simplified example, but there can be more complex reasons. But then, whatever the reason may be, for now, I'm still of the opinion to give engineers control of the assets they are managing. Right? Thank you so much, John, for that love emoji. But then, yes, I'm still of the opinion that to give engineers controls of the assets they are managing is very important. Mario will keep yapping me every time that machine learning will take over his job. But then he accepts that even this machine learning needs engineers to handle it. I'm an engineer myself, I built it, right? Someone that would operate it has to be an engineer that understands it. The same way you learned how to handle Eclipse and the rest. So is it possible for it to implement by itself from what it has learned? Yes, I think it is. Not I think, I know it is possible. If I really wanted to make it just go straight ahead and implement, instead of giving recommendations for me to accept or reject, if it just go straight ahead to implement the recommendation, I could have done that, but I felt no. I certainly don't want my machine going straight to implement. Yes, it causes an issue of it will have an issue. Let me stop sharing so that the moderator will go back. Yes, it gives us the issue of it's no longer real time, right? But then, if you looking at your conversation, I could decide, okay, let me add that. Let me add that as an extra feature, where I can say, okay, since I'm going home now, let me give my machine full control. So my machine recommends and implements for the next 8, 10, 12 hours that I'll be at home, since I'm not monitoring it. But then, I repeat, but then, production engineers work 24/7. It's a shift job. So as you're shifting in, someone else is taking over and is continuing. So the same way you have security men monitoring security cameras, even if you have not seen, I'm sure you have, because most of us are engineers. So you might not have physically seen a large screen where you have multiple security men watching the screen, but I'm sure you have seen it on TV. You have seen it on movie, right? In movies, right? So this we have engineers monitoring dashboards like that. So you could have them watching it. And that is how it is actually. Yes, human inefficiencies happen. Human inefficiencies would come in. But I still do not want to give machines full 100% control. I don't want to give it that. I can't give it that. We could add that as an extra feature. Now you're making me think of adding it as an extra feature. So I might just add that as an extra feature. So if you are going to bed or you feel you're on night duty and you're feeling sleepy, you could decide to just give it autopilot the way we have for cars. Give it autopilot. FAE is laughing, but it's the truth now. You could just decide to give it autopilot and go and sleep. And when you wake up, you continue, you take it away from autopilot. Well, I think I will add that as an extra feature. So the autopilot feature and the engineer control feature. Okay. Thank you so much, Callistus.
Thank you very much, Engineer Duru, for your comments on the questions. Because of our time factor, we may not be able to entertain more questions. So please, if you have more questions, we already told you, Engineer Duru is on LinkedIn. You should reach out to him on LinkedIn. Follow him, connect with him there, ask your questions. I'm sure he'll be more than ready to answer all of your concerns. Thank you very much once again, everybody in attendance. Thank you very much, Engineer Duru, for your explicit explanations. We are excited to have you. Before we move to the photograph aspect, please let us quickly take a closing remark because of our time factor from Oyeniran Sunday Adekola. Please, if you are with us, quickly a closing remark. Thank you very much.
Okay, good evening, everyone. Please confirm you can hear me clearly.
Yes, we can.
Yes, we can hear you. We can hear you.
Yes. All right. Thank you so much, everyone. I guess Kola is not on call right now. He had earlier mentioned that he may have issues with network, so May God help us in Nigeria. So, but I'll just take that
Amen.
instead. So, on to, on to the closing remarks. I want to first of all say thank you to the speaker for the explicit demonstration of his work, because it's not easy to do this. And I want to say thank you for also honoring our invitation, because it's something we had discussed before now, and he was open to share. And also want to also say thank you for how engaging it was. It was very engaging, and we all learned. And from the feedback from the audience, we could see that yes, we gained value for our time. I also want to thank the senior officers on call, from the programs chair to YP chair and co-chair and every other section officer on call for taking our time to be a part of what is our first program as a team, and we can say it was a success. And to every other person on call, from the team members to the other members, whether part of SC Worry or not, you guys are the real MVPs. Thank you for taking our time, and I'm grateful that we got value for our time. The speaker has mentioned that his door is always open, whether virtually and of course even physically. So if you see him, you can always reach out to him, and we'll be glad to offer any form of knowledge and value as said. So, and that being said, I'll just quickly also inform us of our next program, because as we're starting, like we mentioned, they carry last back to back, having value. So tomorrow we'll be having a spectacular CV workshop, and it's going to be a professional program and skill development program where participants will learn what it takes and what should be and should not be on an industry standard CV, and understand ATS systems and all, and also be taken through a practical demonstration of CV design on the platform Canva. So it will be something I believe every young professional would want. So please, let's take it far and wide. Let's try to plan to be part of it by 4 p.m. tomorrow, and also try to get people that will gain value for it to also be a part of it. Thank you so much, everyone. Over to you, moderator.
Thank you very much, our team lead, Mr. Paul Alabi. You did very, very well for taking that up. We are grateful. Once again, thank you, Engineer Duru. Thank you, everyone, for joining us.
Thank you.
Thank you. We have
Thank
learned
you. Thank
but
you
before we go, let us take a photograph. This is how it's going to work. We'll need everybody, about 20 of us present right now, to put on our video. About 20 of us to put on our video. Um,
Have you been able to get some shots? Because some of us can't smile for long.
Hello?
Moderator, please confirm we are good.
okay. Okay.
Okay. Let me check. Group commercial, you sent group commercial? Okay.
Can we?
Let me check.
Hello, moderator. Are we good?
Some news are not showing here at 9. I don't know.
Okay. I don't know if you are
Not yet,
encountering
we are
challenge.
not.
Kachi, can you just? Oh, okay.
Yeah, I've been able to get some shots.
Okay, Kachi, you've done that already. All right.
Yes.
Okay, so moderator Kachi has come to the rescue. So sometimes
All right.
this
Thank you very much, Mr.
sometimes
Kachi.
yeah.
Thank you
Yeah.
very much, Mr. Chi. And that is how we have come to the end of the technical lecture for this week. Thank you very much, engineer. Our team lead, Mr. Paul, thank you very much. You guys are leading us right. We are grateful for your lead. Thank you, everyone, once again for joining us. I think that is how we have come to the end.
And thank you, Faye. You did a wonderful job. Thank you so much, Faye. Oh, boy.
All right, thank you. Good night, everyone. See you tomorrow by 4 p.m. Good night. Well done, moderator. Well done, everyone.